What's going on, MACNA? I hope everyone's having a great virtual conference. I know we would all rather be together in person to talk about reef tanks and to give these kind of presentations, but we're all doing our best to come together virtually. And my name is Jake Adams of Reef Builders, and I have Steve Visser here of ICP Analysis, and we're going to talk about water chemistry, right?
That's right.
Right. So tell us about your current company, ICP Analysis. You've been offering ICP water testing service for a little while. How's that going?
It's going good. We started off about 4 years ago, doing initially elemental analysis to help people understand their aquariums and the balance on it. And we started off with an instrument called an ICP OES, which is very good, and it takes care of salt water real easy for the most part.
So I know a lot of people know you, especially locally. You know, you ran a fish store and you have some history in the aquarium hobby. Just tell us a little bit about your background, I guess, getting into aquariums and saltwater aquariums in general.
Well, I got into saltwater aquariums about 1990, and pretty much back then we didn't really do much with corals outside of soft corals, and it was primarily all about fish. I was all about fish in that time anyway, so that's when I got into it. And then about 20 years after that, about 2010, I got into corals. But I've always loved water quality and water systems. I studied that in college at Colorado School of Mines, and studying chemistry, environmental chemistry, and water systems itself. So, you know, water and fish and ecosystems has just been something I've enjoyed my entire life.
So I find that really fascinating. You know, a lot of us in the aquarium hobby, whether we're into lighting or gear or fish or retail, there's very few people who actually have a professional or academic background in their relative or the related fields. So, but you did. What's funny thing is, we're actually in Golden, Colorado right now, just a couple miles down from the Colorado School of Mines. So you studied water quality and environmental chemistry. Is that right?
Yes, I took several classes at School of Mines on environmental chemistry and water quality itself. But during the time I was getting my chemistry degree, I just always loved water systems and everything that happened inside of it, all the chemistry. That was always my favorite stuff.
What is it about chemistry that you particularly enjoy?
Just how everything is free-flowing inside of a water environment itself. That's honestly where it was. The thermodynamic properties of it and the changes inside of a water chemistry and how everything can react with each other. It just was really, really interesting because you could just explain so many things, and I just enjoyed it.
At what point did your interest in chemistry begin to dovetail with marine aquariums? Obviously, corals are extremely demanding, and the mineral balance and the nutrient management and the trace elements it need. When did you, before you even get into the ICP part, at what point did you really start to take an interest in the chemistry side of the aquarium hobby?
Probably somewhere around 2010. That's when I started, I would say, really keeping some corals outside of just softies. And I then started looking at what was required to take care of your LPSs and then eventually into the SPS. So that's where I started looking at things and understanding what was necessary to keep corals alive and the balance. And I always thought it was just, to be honest, a little bit crazy to think that the broad parameters that we used to call for like alkalinity that say, oh, well, we test it 1 week and it's 8, next week it's a 9, and thinking that 1 DKH was perfectly acceptable, and in reality, corals don't really like that so much. Mm-hmm. And same thing with just the entire environmental chemistry, water chemistry. It then relates down to your calcium, magnesium, and even all the trace elements, Corals love consistent environments.
I'll tell you one thing. When I started in the reef aquarium hobby, I was much younger. I didn't even have high school background or college background. It was really, really hard to wrap your head around what all this stuff means. It took me 5 years, literally 5 years, to realize that buffer and alkalinity and carbonate hardness was the same thing, just fumbling through the aquarium hobby, and things have clearly come much further since. You know, in the early days of the aquarium hobby, it was just all right, what's your salinity, what's your temperature, what's your calcium? But
Yeah.
even, you know, alkalinity was there, but we didn't really talk about it, and now we know that like alkalinity is 20 times more important.
Exactly. I mean, it's a foreign language initially. It really is. That's what I used to always tell people about science is just like a foreign language. And as soon as you start to understand the foreign language, then it starts to all make sense. But until then, no, you don't understand, and it's gobbledygook.
So let me ask you, we're going to get into the meat and potatoes of, you know, our discussion, but I have to ask, what were some of your favorite test kits when you got into the aquarium hobby, and why? What were some of the tests that, you know, you use all the time, and why?
Well, I went with what was available out there, and your little titration test kits. And Salifert and ATI were two that, you know, were readily available at places I went to. And so you use them. And I thought, wow, this stuff has such a broad range, you know, for things. And while I had worked in some analytical laboratories, and we had done titration stuff repeatedly on it for some accuracy, I thought, this stuff really should be a lot more accurate. And I knew at that time that it was just, okay, this is ballpark figures, and yeah, okay, that's fine. I mean, this is what we have to work with, and
I don't
that's
remember
what you use.
which brand it was, but there were certain product lines, because they weren't all made by the manufacturer, where you got calcium or magnesium in 50 part per million increments, and it was just with a plus or minus 50 ppm, you know, variance range. So you must have known all along that you were already familiar with tools, you know, from your analytical work in college. You must have known that there's better tools available. And did you know, like a long time ago, that ICP or some device like it was gonna, you know, become a part of the aquarium hobby?
No. I mean, when I graduated in 1994, ICP was in its infancy.
Oh, okay.
There was not very many places that had an ICP outside of probably some of the big government and big laboratory stuff, because it was really new. So it was not even something we discussed in college,
Oh, right.
and even that a college had.
So when did inductively coupled plasma, optical emission spectrometry hit your radar? Like, when did you start, like, you know, kind of entertaining doing tests? Because I think you got the machine for yourself first.
I did.
And then you decided to offer it as a service. So when did you start, when did your gear start turning about ICP?
Goes back to the San Diego MACNA.
Okay.
And I don't really remember what year that was, but I went there because I had my fish store going, and I was looking for new products to carry and see things. And I just discovered then that, okay, elemental analysis is becoming something that Europe is really big on, and, you know, starting to grow out there, and that it's starting to make an issue or a presence in America. And it's like, well, I should take a look into that, because I have a lot of money in corals, and I had a lot of money in fish and other things, and I wanted to be analyzing various aspects of what I was doing for taking care of everything. So I just decided I would buy one of the machines.
I have to, if I can be a little bit honest here, you know, I knew you as a local fish guy and as a local fish store, and had no idea about your, you know, chemistry background or how much you dive into stuff. When you initially said you were going to get ICP machine, I was like, oh boy, good luck with that. Like, and I knew you were going to get it, but I'm like, how is he going to learn how to do it? And then it's after you set up the machine that I learned that you have this extensive experience in, you know, chemical processes, right?
Yeah, I understood a lot about the chemistry of what was going on, and I understood about instrumental chemistry, or I should say about how the instruments are designed and how they operate. the thing was, it all comes down to sometimes with some of these instruments, the software of understanding how to set up the software and how to utilize the software to then analyze stuff. I mean, an ICP OES is great for analyzing, a lot of elements, at one time, where before the ICP, we just utilized some other instruments that might only pick up 6 to 10 elements at a time, and then you have to change out some instrument parts and do some others, and that all had to do with the wavelengths of light that you're changing parts for. And so the ICP was just like, wow, you can analyze and do all these elements inside of a couple of minutes, without changeover parts. That was great.
But you developed the protocols that's used on your particular machine, right?
Oh yes, all the protocols and everything are developed, and now I have lab techs that take care of that source after everything was looked at by myself, and then I had the manufacturer of the instrument, Agilent, where they sent out their PhD chemists that were, well, they're the ICP experts, and they verified all the stuff and went through and made adjustments to what I had already.
Oh, fun. Fun. You had some professional pinch hitters to give you some pointers.
Yeah, I didn't want to do this without being able to say, hey, we're doing the right things. And we've had, PhD specialists in ICP that the manufacturer even, has, and they know all about this stuff. They were able to make recommendations on how to create our protocols on everything.
So I think it's really interesting. It would be really interesting to know from your perspective as someone who actually performs the test, what is ICP OES really good at? What does it excel at? But where does it start to fall a little bit short?
ICP OES is great for the saltwater part, it's great for macro elements. I mean, your calcium, potassium, sodium, magnesium, those things are great. And even down into strontium, so everything that's in your parts per million or parts per thousand, it's absolutely wonderful for. And then as you start getting into parts per billion elements, your trace elements, it starts to fall apart a little bit. It depends on the element and what level you're wanting to look at. And this is one reason why I believe nobody likes to talk about detection limits, is because when we want to look at trace elements in salt water, we want to look at really low parts per billion because that's what salt water has.
That's the natural seawater levels of some of these very minor trace elements.
Yeah, and when I say minor trace, I mean we're talking about less than 100 parts per billion. So really small. ICP OES is good for a lot of things down to maybe 50 parts per billion. You can get down to low parts per billion on some of the heavy metals, but you really have to then watch out for a lot of the interference that can come from other elements on it to not interfere. And saltwater just has a lot of interfering elements that makes it difficult to get into the low parts per billion.
Would you describe this interference as the limiting factor to the OES flavor of ICP?
Oh, it definitely is. I mean, there's a reason why environmental labs don't use ICP OES on a lot of elements itself outside of, in general, heavy metals. That's what they use an ICP OES on, is heavy metals, because they know they can get down, if they're just doing water, standard groundwater with heavy metals, they can get down to 10 parts per billion. But you start going above that, and no. And if you want a better resolution, you need to go to an ICP mass spec.
Very cool. I'm actually excited because we're about to get to the meat and potatoes of this presentation, which is your new approach to analyzing aquarium water. But before we dive into that, you must know this, that aquarists, hobbyists, some of the more critical ones, will send 2 samples to different companies or 2 samples to the same company, and the results don't typically agree with each other. Do you think that's mostly at that detection limit zone where you're talking about things that are less than 1 ppm that it starts to get a little hazy?
No, it's less than a part per million. Yeah, that's where things can get crazy. But the honest truth is, I've had people say the same thing about calcium. I've had them say, that my calcium, was this number with you, and it was this number with, two other companies, or this number with this company and this number with another company, and none of the three really match up. And this is just another drawback, actually, as you mentioned that with ICP OES, is that as the machine runs, you have to rerun the standards constantly in order to try to maintain calibration on it.
Wait, you have to run them all the time? I figured you'd do a calibration run and you'd be good for 24 hours.
No.
I don't know. I mean, I don't know. I just kind of made assumptions that.
We actually run 10 to 12 samples, something like that. I'm not remembering off the top of my head the most. And it gets, the standards get rerun.
Do you run like a standard for one particular element, or like a cocktail for groups of elements? We
have a couple of cocktails, and our cocktails come from, they're certified standards that we buy from companies that they're called NIST certified standards. Mm-hmm. So we could make our own standards, but we want every customer to know that we're actually buying from a certified company. It's sort of like the 9001 certification on everything, by making the NIST. They are 9001 certified, plus they're NIST certified. All these government organizations or independent organizations certify these standards, saying this company knows what they're doing, and they give you what you want.
How do you know how often to run those standards to double check your testing? Is it after so many tests or after a certain amount of time?
That was experience.
Oh,
I'm just going to say that when you start running, you start playing, and that was part of my early trials and tribulations. Where you think, okay, I can run 30, 40, 50 samples without it adjusting. Well, a lot of elements you can actually do that with, but there are always a few elements that are buggers that you can't do that with, and you really need to run that standard frequently. So as a result, we run it about every 10 to 12 samples.
Every 12 samples you're running standards through there?
Yeah.
Wow. I mean, that's got to be tedious and time consuming, and just add to the labor process of trying to run all these tests.
No, fortunately it's automated.
Oh, well, there's that. There's that too.
You put all the vials in and you put them in the appropriate thing, and you tell the computer, rerun the standards every so many samples, and then you're just sitting there once it's going. The tech is sitting there analyzing the data, just reviewing it as it's going through, and if he sees something that's out of whack or something that's not there, maybe he'll rerun the sample to see what it is, because sometimes people send us some really weird stuff just to see what it is.
So tell us of what your future roadmap looks like.
It's going to be with ICP Mass Spec, and this is honestly what the manufacturer of what we bought our ICP from, Agilent, had actually pushed us to do initially, and I didn't do it, and I should have. The mass spec is 1,000 times more sensitive, meaning it'll go down into the accuracy into low parts per trillion if you set things up right. And at this moment...
Did I hear you right?
Parts per trillion.
You said parts per trillion.
Yeah.
Now, I want to learn a little bit more about the mass spec, because you just told me about this a couple days ago. I'm still trying to wrap my head around it. So the ICP OES machines that are used now by a lot of different testing services, they use spectral emissions, right?
Yes.
And the mass spec measures
the mass
of the particles, just of the atoms that are being plasmid.
Particles and atoms are smaller than, they're part of the stuff that makes up the element, but they're just measuring the mass of the element.
Okay.
So when we shoot everything into a fine mist and enter it into the plasma, 5,000 degree plasma ball that is there, and to break up the chemical bonds, the elements then go through and hit a detector that measures the mass of it. By measuring the mass, we eliminate a lot of the interference. I bought the ICP mass spec as another thing to start playing with and learning about. And the software was the biggest challenge, utilizing it, because it is capable of so much stuff, and there really isn't a manual on it. So learn and utilize tech support as you can after initial training is given to you.
And those standards, right? Because you're using standards, you know what you're putting in, and so
Correct.
you know what you should be getting out.
Correct. And so just like with the OES, we buy standards for the mass spec, and they're the same company and the same type of standards. However, we just are able to break things down a lot more into diluting it down. So where we might dilute some stuff down to 1 part per million, we'll dilute this down to 10 parts per billion. And we'll then calibrate everything and do like a 4 to 6 point calibration curve depending on the element and the standards that we have.
So what does this mean for the Aquarius? You know, are we going to be able to take the ICP results with more faith and just have more trust in them? Are we going to be able to detect, you know, elements even further down than before? Because I'm really interested in the biochemistry of certain trace elements. It just doesn't seem like the resolution is quite there yet.
With our calibration, our accuracy is good into about 100 parts per trillion. And with some of our trace elements that we're concerned about, we want to know, do we have 1 part per billion, 5 parts per billion? And with the OES, I would have loved to have used a calculator and told people what to do, but I saw the limitations as I started doing stuff, and I was going, I can't tell people to add something, because here's the problem with trace elements, is if you add too much, it's a toxin.
Yeah.
And that's a big problem.
Yeah.
You don't want to
It's
overdose.
just a very fine margin of error, right?
Yeah. So it's very delicate.
So tell me, how are you going to report back those results, and how are you going to help communicate the kind of dosages that you want to recommend to people?
So what we've created on our software is when we run a test, good samples are actually in white. So when you click on an element and it's white, that means everything's good. When it's yellow, it means it's low, and you should take a look at it. When it's red, it means it's high, and that's bad. And typically, you know, you might be able to buy something to reduce it, but most of the time we just suggest doing a water change with a good quality salt mix to drop your stuff down to proper level. But in order to dose your trace elements, we took into the fact that we took all these trace elements that, for instance, other companies are offering, and there's only a few companies offering trace elements in a wide spectrum.
Right.
And we took those and we put values of what's safe and for your aquarium and what isn't. So when it goes below a certain threshold, so say one element drops below 5 parts per billion and you want it to be 5, you know, say your safe range is 5 to 7. If it drops below 5 and you're at 3 parts per billion, it's gonna show up as yellow. And then at the top of the screen, it says, select your product. This element is below dose, select your product, and then it tells you how much to add to it.
So I guess one of the things I was getting at, though, is how are these results reported back? Because right now, I know there's been some services that literally send you an Excel spreadsheet that's just makes your eyes hurt looking at it.
Our app, we designed our app so that it actually looks like a bit of a periodic table. So we have boxes with all the elements, and then it has the value in there. Now, the way we organized our element and our chart stuff is a little bit different. I mean, it's not like the periodic table, and we didn't do it alphabetized.
Right.
We actually first put our macro elements, then we put our trace elements that are commonly dosed, and then after that we put our toxins to other elements contaminants that we don't really know much about.
But you have an app.
It's an app.
Okay.
We have an app for your phone, and we also have a web app that shows a lot.
So one thing I've used the web app a little bit that I like is you have a QR code to quickly connect a water sample to one of the testing vials.
Yes. We have 2 ways to connect a sample to it. And new tests that we're sending out, like right now, every test that goes out with the ICP mass spec has a QR code.
So you're offering the mass spec service already?
We are.
That was going to be one of my follow-up questions.
Yeah, it's on our website itself. We haven't started to offer it out to the retail stores yet.
Okay, all right.
We're just wanting to make sure everything looks good and hit our customers and get feedback of what they would like to see as feedback before we put it out to everybody out at retail stores and everything. So it's just
is the ICP mass spec testing service, is it fine-tuned for saltwater aquariums, or are there other applications that you could use this for?
That's the other thing we are doing, is we're taking the ICP mass spec service and we're actually offering it into people's RODI units and drinking water. The drinking water is going to be a big thing for us because we've come up with a RODI filter system with a bladder tank and a filter, and it's really neat because we're going to give a customer initially a mass spec test to tell them what's in their tap water and what they're drinking, and show them what's in there and say, once you add our RODI filter to it, this is how much we're removing. And then every 3 months, when they sign up for our service, we're going to send them the pre-filter, the carbon filter, and a mass spec test, because to guarantee that they always have clean water. So you should always change your pre-filter and carbon filter every few months anyway. And nobody knows how much water ever goes through their stuff, and they never know when to change stuff. So we're going to help them out with that.
It's kind of astounding that there has to be like thousands of companies offering water purification solutions, whether it's softeners or DI or RO or whatever, but I can't recall any company offering either a water quality testing service, let alone paired up with a water purification system. I think that's so simple. It's like, why hasn't anyone done this before? Clearly, it's because the mass spec is just now becoming, practical to use at your scale.
I don't have the answer to that. I'm going to say that because the mass spec has been out for a very long time in environmental labs, but they're environmental labs. They're working with government money in essence, and they don't care about the public as far as that market goes. I look at what can we do for the average consumer. And the average consumer nowadays is very concerned about what type of water they're drinking, what's coming out of their tap, which is why aquarists buy an RODI to filter out everything, and they want that water quality to be better than what they're drinking to go in. But why should it be that way? Why shouldn't they also have good quality water drinking at a fair price to know that every 3 months, if they pay $15 a month, in essence, they're going to have clean water and know when it's time to change their DI resin or their reverse osmosis filter just by the science.
Very exciting. Well, I know there's been a lot of people, I think all reefers know about ICP. There's some who were all in, there's some who have done, a few tests, but I think the majority of reefers right now, they're just kind of been waiting for something new to just, quelch their fears and their apprehension about actually trusting the results that come out. But it really sounds like mass spec is the promise that we're told from the initial launches of ICP. So I'm really excited about this testing service. Is there anything else you wanted to say to the MACNA attendees while you have their attention?
I would say just, if you're looking at ICP or haven't tried it, try it out, especially this weekend, because we will actually be running some sales on the mass spec, because you'll see a difference in the accuracy and how much is available. But the honest truth is, we have the confidence that we'll tell you how to dose other companies' products into your tank without a problem.
And you don't sell any additives, right? You're trying to go for the water purification and the pure water, but you're going to help create some synergy with all, chemical suppliers.
Correct. We are not selling our own product. At some point, we might go ahead and add our line of trace elements, but there's a lot of products out there that people trust and that are good. There's nothing wrong with saying, hey, this is how much you need to add of your favorite product. Everybody has their favorites in their region of what's available and what isn't.
That's one of the things I always say, what should I get? What does your fish store use? You can get some feedback from the local guys. So where could people go to learn more about this new ICP mass spec testing service?
You will find more information on our website of icp-analysis.com. And we have a new website there. We're working out some of the little things because we just launched it, but it's a beautiful site. It has a lot of information, for everything from saltwater to freshwater tanks to drinking water. and the services that we're providing.
Very cool. Steve, it was really great to pick your brain about this new service. I hope you guys got a lot of information about this sit down with ICP Mass Spec. I think we could talk about any point for hours and hours, but we really try to boil it down to fit it into the program here at MACNA. So thanks for having us. I hope you guys are enjoying the show, and hopefully we'll see you guys in person at next year. Later,
Thank
guys.
you.